The third physical property that we're going to discuss deals with the solubility of organic compounds. Now, before discussing solubility, I'll briefly give you an overview of which compounds are soluble. There are two types of solvents first. One type of solvent they're called polar solvents, and I'm going to explain what I mean by polar solvents in detail a little later. So the first type of solvents is polar solvents, and the substances that are soluble in polar solvents, they are alcohols, carboxylic acids, and amines. These substances are soluble in polar solvents. Then there are other types of solvents which are called non-polar solvents. The substances that are soluble in non-polar solvents are alkanes and alkenes, which are soluble in non-polar solvents. And there are other substances like esters which are also slightly soluble in non-polar solvents. Now, what do I mean? I'll give you a few examples of which substances are polar solvents and which substances are non-polar solvents. When we deal with polar solvents, one very common solvent, that's water. That's basically a polar solvent. Then you have different alcohols which are also considered polar solvents. And when we deal with non-polar solvents, we have substances like CCl4, which is a non-polar solvent. We have kerosene, that's also a non-polar solvent. So you must have noticed that if you want to clean your clothes properly, you sometimes do put kerosene on them to dissolve stains which are not soluble in solvents like water. Now, in the next part, I'm going to give you a detailed understanding of what we mean by polar and non-polar solvents, and I'll give you a concept of solubility. Now, the first thing that we're going to deal with, and I'm going to explain, are polar molecules. So, now, polar molecules are molecules where the electrons are not evenly distributed, which means that they have regions. The molecule is going to have a region. It's going to be having regions of partial negative. This delta is a Greek symbol. It represents slight or partial in chemistry. So a polar molecule is going to have regions of slight negative and simultaneously slight positive charges, which means that the electrons are not evenly distributed. And as an example, I'm going to give you water. I'm going to describe water, which is a polar molecule. Now, water, the case of water is that it has an oxygen atom which has hydrogen bonded to it. Now, oxygen has lone pairs. It has extra electrons in its outer shell, which are not involved in bonding. Now, if you look at an oxygen atom, those extra electrons are going to create a slight negative charge on the oxygen atom. Similarly, hydrogen only has one electron which is being shared with the oxygen atom. So this hydrogen also is sharing one electron. Now, hydrogen just has one electron, which exposes its outer nucleus. So this hydrogen atom, its nucleus is very exposed. Remember, nucleuses of atoms, they contain protons which are positively charged. So if anything comes close to hydrogen, it's going to experience a slight positive charge. So a water molecule is polar, and the reason it's polar is that it has regions of slight negative and slight positive charges. Now I'm going to describe what type of intermolecular forces occur when you have polar molecules and polar solvents. Let's think of methanol and uh, let's think of methanol, and we have. I'm going to draw a methanol molecule. It's going to look like this. There's going to be a CH3 and an O and an H. Now again, this oxygen is going to have a slight negative charge because it's got lone pairs, and this hydrogen is going to have a slight positive charge. Now methanol is a polar molecule. Now what happens is, eventually what happens is that you have this hydrogen on the water molecule is going to be attracted by the oxygen on the methanol molecule, and similarly this hydrogen is going to be attracted to the oxygen of the water molecule. So you have these forces of attraction present between molecules. So when you have polar substances and they're being dissolved in other polar substances, those polar molecules, one polar molecule is going to attract the other polar molecule. And what eventually happens is, let me instead of drawing the structures, let me just draw molecules. Let's say this is these are water molecules. I'm just going to draw symbols to represent these water molecules. And these are methanol molecules. Let's draw another one. Now what happens is all these molecules will be attracting each other. For example, this water molecule, the one drawn in red, is going to be attracted to the blue methanol molecule. Similarly, this molecule would also be attracted to this molecule over here. This red water molecule will be attracted to both the methanol molecules in all directions. So all of these molecules will be attracting each other because they're all polar. These water molecules, the red molecules, will also be attracting each other. So in a way, they're all attracting each other. So I'm going to draw all the forces of attraction which can be present in this particular case. So all the molecules will be attracting all the other molecules. These are intermolecular forces. Now, since all the molecules are attracting all the other molecules, one polar molecule is attracting the other polar molecule. So what happens eventually is, when you mix two polar solvents together, whenever you mix two polar solvents together, so whenever you mix polar solvents or polar substances together, they will remain mixed. And the reason that they are going to remain mixed is because they will all be attracting each other. So due to the intermolecular forces present between them. So that is the case when polar solvents dissolve in polar solvents with other polar solvents. Similarly, we have non-polar molecules. Now, non-polar molecules are molecules where the electrons are evenly distributed. So in these molecules, electrons are evenly distributed, which means that they don't have no regions present, no regions of slight negative or slight positive charges are present. So that's your typical nonpolar molecule. Even distribution of electrons with no slight or negative charges present. I'll give you an example of such a molecule. For example, we have bromine, which has electrons which are evenly distributed. So a bromine molecule, a Br2 molecule, is not going to attract or repel other substances, or in other words, what we can say is they are going to attract or repel other substances, but the attraction or the intermolecular forces are going to be extremely weak. So we cannot, they would be very weak intermolecular forces present between molecules. So so Br2 has very weak intermolecular force. It's not going to attract or repel other substances. Similarly, we can have another molecule where you have, let's say, there's a CCl4 molecule where the carbon is bonded to 4 Cl atoms. Now, this is also a completely nonpolar molecule. Its electron distribution is evenly distributed. It has no slight negative or slight positive regions. So what happens when we mix two nonpolar substances? Whenever we're mixing two nonpolar substances, nonpolar substances, they will dissolve in each other. And the reason why they dissolve in each other is, let's say we have a bromine molecule, and this red dot represents a bromine molecule. So let's say I've drawn 5 bromine molecules, and I'm going to draw similarly 5 CCl4 molecules. Let's say there's another one over here. Now the thing with when you mix these two substances together is that they will not mix with each other. They're not going to be attracting. There would be no force of attraction present between the two molecules. So if you mix them together, they're going to remain mixed. They're going to remain mixed, and the reason is because they're not attracting each other, so they're going to stay exactly the same. They're going to stay exactly in the same position where they were before. So no intermolecular forces are present. Are present. So if you mix them, they're going to remain mixed because they're going to stay in their positions. No one is attracting them, so they're going to remain where they were originally. So they all remain mixed. So far, that what we have studied so far is that polar substances dissolve in polar solvents. That's the first thing that we studied, was that polar substances dissolve in other polar solvents. For example, water is going to dissolve molecules that have regions of partial positive and partial negative charges. On the other hand, non-polar solvents or non-polar substances are going to dissolve in non-polar solvents. So the only thing that we haven't studied so far is that non-polar and polar substances do not mix. And I'm going to give you an example of why they will not mix. We've studied the previous two in detail. Now I'm going to take one polar molecule. Let's say, for example, HCl is a polar molecule. It has regions, chlorine has a partial negative charge in HCl. and hydrogen has a partial positive charge. And I'm going to I'm going to draw a few HCl molecules. So hydrogen has a partial positive charge. Let's draw another HCl molecule. Negative and partial positive charges. Then I'm going to draw another molecule. I'm going to draw a non-polar molecule. Now, bromine is a non-polar molecule. So bromine has this molecule of bromine has no region of partial negative or partial positive charges. So I'm going to draw a few bromine molecules now. Now, when you mix these two substances together, for example, the way I've drawn them, I'm showing that they are mixed together. What's going to happen is that HCl molecules are going to attract each other. This chlorine, partial negative, is going to be attracted to this hydrogen atom, which is partial positive on the other HCl molecule. Similarly, this chlorine negative is going to be attracted to the hydrogen atom on the other HCl molecule. Now, these three are attracting each other, whereas these bromine molecules over here, they will not exhibit any force of attraction or very weak force of attraction. They will not be having very strong intermolecular forces. So HCl molecules are attracting each other. So eventually what's going to happen is that these HCl molecules are going to be pulled together. They will be, let's redraw this. Let's try and figure out a picture of this mixture after a few minutes. So this was our previous case. Now these HCl molecules are going to be attracted to each other. So hydrogen had a partial positive, partial negative. This hydrogen was partial positive and partial negative. This is also positive and negative. Now you have these molecules and they're strongly attracting each other. So this blue line represents the intermolecular force of attraction or the electrostatic force of attraction which is present between these HCl molecules. So what's going to happen to the bromine molecules? Let me correct that. What's going to happen to the bromine molecules is that they would form a separate layer because they're not attracting each other, but the HCl molecules are attracting each other. So they're going to push these bromine molecules out of the way. And what eventually happens is that two separate layers are formed as all the HCl molecules attract each other. They group together and they form one layer, whereas the bromine molecules are pushed aside and they're going to form another layer. And this is what you generally observe. For example, a real world example could be this is what you're going to observe if you mix oil and water. What eventually happens is that since water molecules are polar molecules, they're attracting each other very strongly. So let's draw a beaker. And since the water molecules are attracting each other very strongly, these molecules will have strong intermolecular forces which are attracting each other. They're polar solvents. This is water. And since they're attracting each other, they're going to be grouped together. They would be very close to each other and they're going to form a separate layer. And oil would be pushed aside. So if you mix them temporarily, they're going to separate again due to the strong intermolecular forces present in water, and they're going to form a separate layer back again. So this was the entire concept of solubility, that polar solvents dissolve in polar solvents, non-polar solvents dissolve in non-polar solvents, and polar solvents and non-polar solvents or substances, they do not mix together.